Hello, I'm Philip Stoughton. I'm at SMT in Nuremberg 2014, and I'm joined by Martin Hart from Topline. Martin, thanks for stopping by to chat. You come by to talk about CCGAs. Let's start with the very basics. What does CCGA stand for?
So the acronym CCGA actually stands for column grid array. So the first C would be a ceramic column grid array.
Okay, and what's behind that technology? What's the purpose of those? Why do we need
so
CCGAs?
CCGAs are about 10 times more reliable than a BGA.
Okay.
So primarily CCGAs or column grid arrays, most important influence is when you have a large ceramic substrate that's being mounted onto an FR4 board or a polyimide board, because there's a large CTE mismatch between the property of the ceramic and the property of the board. So the columns, let's say, absorb and take the shock out of the CTE mismatch. Your ceramic is moving at a certain CTE or coefficient of thermal expansion. Your board is, and there's a mismatch. So you've got your board, your ceramic. Eventually a BGA will rip off the board, so it'll delaminate. Column grid array is more reliable in that the columns, actually I brought a model to show you that this is actually, I'm not sure, it's maybe 100 times bigger than the actual column. The actual column is only 2.2 millimeters high. And so between your ceramic, which would be mounted on the top, and a board, these can actually absorb a lot of movement. And that's the main purpose of it.
So the reliability comes in the bond to the substrate rather than the actual device itself and the silicon. And what kind of applications have driven this requirement? Is it the automotive industry or any particular sector?
Well, actually, the main sector is the aerospace, the defense, military. That's the first area where they're using a large ceramic substrates. And as they famously say, there's no repair station in space, so the parts have to go up and be reliable for well over a 20-year life or more, and BGAs cannot really do the job, and columns do. So the future markets that will be expanded will be automotive, where there's ceramic components inside of the engine compartment, or where there's, let's say, harsh environments of temperature, vibration. So automotive is another market, and as well as downhole drilling. There's more and more electronics going down into the earth. And
once it's down there, you don't want to bring it up to fix it.
Yes, exactly.
Okay, and you've got as I say, you've got the columns there. How does that differ in terms of the manufacturing process to a BGA? Okay,
well, that's a good question, because BGAs use a round spherical solder ball, which is very easy to assemble. The balls roll. Typically, they roll right through a stencil and land onto the substrate. Well, obviously, these are cylindrical, and there's a much more difficult, but not impossible way to assemble these.
So it's a little bit more complicated.
Yes, it is.
And as always with these things, when we've got a big change in reliability, we often have a playoff in terms of cost. And that's maybe why it's been taken up by a high rel industry like Mill Aerospace first. How big is that playoff, and is it coming down?
So yes, there is a substantial difference in price between a BGA and a column grid array. The price is coming down with an increase in volume. And one of the areas is where customers want to actually rework their BGAs, remove the solder balls, and replace them with the columns. So that's an area where that will build volume, which will then mean economies of scale, and the price will come down.
And what about in terms of the kind of peripheral services around there, in terms of the rework techniques, in terms of all that? Is there a whole bunch of new equipment there, or new techniques, or how do people access all that change?
So the basic equipment is the same. You need ovens, you need some robotics, but the process is different because these are cylindrical, and they don't roll.
They roll in one direction,
Yes.
not in every direction.
Exactly. Now, we've actually invented something called a pin pack. We filed a patent on it, and it's a small plastic piece that have the columns preloaded.
Right.
So previously, what was driving the high cost was that you literally had to take one column at a time and load it manually with tweezers.
Right.
And so it could take an hour to load up your fixtures, your array. So with our pin pack now, it literally you can mount the columns in 1 minute.
Drop them in.
They're preloaded.
Okay.
You pull back a tacky tape. The columns then fall right into the fixture, and with 1 minute you've loaded it up. That seems to overcome a major barrier or obstacle to quick assembly.
Okay, and finally, just tell me about the role of Topline in that.
Yes.
And from Topline, what your route to market is. Is it through distributors, or is it leased intellectual property?
Okay, so we sell products, we manufacture products. What we manufacture are the columns themselves. Mm-hmm. There's 3 types. I'm only brought models of 2 of them, but this is a plain column that's actually a PB90 SN10 material. This is a copper wrapped version, and then there's a new spring, micro coil spring invented by NASA.
Okay.
NASA approached Topline. We purchased the patent from NASA, so now we're producing also the micro coil spring.
Okay, and that's literally
it looks like a spring. Yes, and it does absorb more shock.
Yeah.
So what we make and produce are the columns, and then the tool set to allow customers to attach the columns.
Okay,
yes.
And beta testing, or what kind of phase in development is, or in terms of market take-up is this product?
Okay, good question.
Is there any stuff in space yet?
Okay. None of our material is in space. It's
space.
all in the lab,
Yeah.
and it probably will stay in the lab for a good year through testing.
Yeah.
Yes.
It takes a while to get up there, doesn't it?
It does.
Things. They're not going to put it up there unless it's going to work.
Right.
Martin, sounds exciting. I'd love to speak to you again in 12 months or so, find out where it's going and whether we have got stuff up there using it at that point. But in the meantime, enjoy the rest of the show, and thanks for your time.
Thank you very much.